Assalamualaikum. Today I am going to present how to find the second moment of inertia. Find the second moment of inertia of built-up section shown in figure about x-axis and y-axis passing through the center of gravity of the section. First of all, we calculate the area of figure 1, and after that we calculate the area of figure 2, and then we calculate the area of figure 3. That flange width is 150 mm and thickness of flange is 50 mm, and this flange width is 100 mm and thickness of flange is 50 mm. The web depth is 300 mm and web thickness 100 mm, so 50 mm. The total depth of the figure is 400 mm. First of all, we calculate the area and then we calculate the distance from reference axis to centroidal axis figure 1, that is called y1, and the next we calculate the distance from reference axis to figure 2 local axis, that is called y2, and the next we calculate the reference axis to distance from figure 3 local axis is called y3, that is y1, the distance from reference axis to this axis. रेफरेंस एक्सिस से लेकर जो ये फिगर 1 है, इस एक्सिस के सेंट्राइड तक जो डिस्टेंस होगा वो हमारा y1 होगा, और जो फिगर 2 है इसके सेंट्राइड से लेकर जो वर्टिकल डिस्टेंस रेफरेंस एक्सिस तक होगा वो y2 होगा हमारा, और जो वर्टिकल डिस्टेंस फिगर 3 से लेकर रेफरेंस एक्सिस तक डिस्टेंस होगा वो हमारा y3 होगा। यहाँ से यहाँ तक y3 है, here to here distance y2, the distance from reference axis to this local axis is called y2, and the distance from reference axis to this figure of the center is called y1. And after that we calculate h1, h2 and h3. What is the distance from h1, h2 and h3? The distance from centroidal axis to figure 1 local axis is called h1, that distance. And what is the distance h2? The distance from centroidal axis to figure 2 local axis, vertical distance, that is called h2, that distance, h2 like that 81.72, and what is the distance h3, the distance from centroidal axis to local axis is called local axis 3, y3, the vertical distance is called h3, that distance. Okay, What is the x bar and y bar? The distance from reference axis to central axis horizontally is called x bar, that is 75 mm. The structure is the symmetrical about y axis, so the x bar distance is always same. That is x bar and that is x bar and that is y bar. Given at a figure, depth, flange width, flange thickness, web thickness, area. Area figure 1 is 7500 mm square and area figure 2 5000 millimeter square and area of 3 15,000 millimeter square. First of all we calculate the area. We calculate the area 1, that is flange width and that is flange thickness. The area of figure 1 7500 millimeter square, area of figure 2 that is flange width, that is flange thickness 5000 millimeter square. The area of 3 is 15,000 millimeter square, that is web depth and that is flange web thickness. The total area of 27,050 500 mm square. Now we calculate the x bar and y bar distance. y1 375 millimeter distance, y2 325 millimeter, y3 150 mm, x1 75 mm and x2 75 mm and x3 75 mm. Because the structure is symmetrical about y axis, the x bar distance is always same. Formula of x bar, that is h1 distance 131.81 mm, that is figure 1 distance, centroidal axis to local axis distance 131.81 millimeter square, h2 81.72 mm and h3 93.2 mm. Formula of x bar and y bar, x bar area 1 x1 plus area 2 x2 plus area 3 x3 divided by area 1 plus area 2 plus area 3. Y bar area 1 y1 plus area 2 plus y into y2 plus area 3 into y3 over area 1 plus area 2 plus area 3. X bar that is it, x1 that is area 1 x1, area 2 x2, area 3 x3 over area 1 plus area 2 plus area 3, that is 75 mm. Y bar, that is area 1 y1 plus area 2 y2 plus area 3 y3 or area 1 plus area 2 plus area 3, that is 243.18 mm. That is y bar, that is x bar. Now we use parallel axis theorem because the centroidal axis is parallel to that axis, so we use the parallel axis theorem. जो फिगर का सेंट्राइड है उसका जो सेंट्राइडल एक्सिस है और इस जो ओवरऑल फिगर का सेंट्राइडल एक्सिस है, क्योंकि ये इस एक्सिस के पैरेलल है, इस वजह से हम पैरेलल एक्सिस थ्योरम यूज करेंगे. Now we use parallel axis theorem. I x-axis is equal to Ig1 plus area 1 h1 का square plus area 2 plus Ig2 plus area 1 h2 का square plus Ig3 plus area 1 h3 का square. Ix is equal to BD cube over 12 plus area 1 h1 का square plus BD cube over 12 area 2 h2 का square plus BD cube over 12 area 3 h3 का square. That is 409.32 into 10 to the 6 millimeter की power 4. That is moment of inertia about x-axis. Now we calculate the moment of inertia about y-axis. Because the structure is symmetrical about y-axis, that distance is 0. Because the centroidal axis to reference axis distance is 75 and x1 distance to centroidal axis distance is 75. The same 75 minus 75 is equal to 0, but the r distance is 0. Now we calculate the moment of inertia about y-axis. The formula of moment of inertia about y-axis is equal to y-axis is equal to Ig1 plus area 1 h1 का square plus Ig2 area 2 h2 का square plus Ig3 area 1 into h3 का square. Iyy is equal to db cube over 12 plus area 1 h1 का square plus db cube over 12 plus area 2 into h2 का square plus db cube over 12 area 3 h3 का square. That is equal to 21.35 into 10 to the 6 millimeter की power 4. Okay, thank you.